Okay, so before we get started with these 6.7 notes, here's your bad joke of the day. Why do snails move slower when they take their shells off? The answer is because it makes them more sluggish, right? If this guy takes off his shell, he's a slug. So, haha. Okay, so we are going to get started with these notes. So again, make sure you have this note sheet and something to write with. Section 6.7 is about the fundamental theorem of algebra, and that theorem is going to help us answer these two questions. How do you know how many solutions a polynomial has? And then how do you find those solutions? All right, well, the first part of this theorem tells you that any polynomial has at least one solution. And that solution, or root, sometimes we call that, is in the set of complex numbers. The second part we've actually already talked about. The real or imaginary solutions counted, even the repeats, of any degree polynomial is the same as its highest power. And we're actually going to start with that second part of the theorem in these first two examples. What we're asked is how many solutions do each of the following polynomials have and what are they? So in order to do this, you're going to have to tie all of the skills that you've learned for solving. So you have to know how to factor, you have to use that rational zero theorem. Remember, that's the theorem that gives you the PRZs of a function. You have to know how to use synthetic division, and now this new fundamental theorem of algebra. So let's look at example 1. I notice that the degree of this polynomial is 1, meaning it has exactly one solution. All right, so we already answered the first part of this question. Its highest power is 1, giving it one solution. So now to solve it or figure out the zeros, you simply take that equation and set it equal to 0. So we know how to solve this. Let's add 1 to both sides. It's going to give us 2x equals 1. And if we divide by 2, we end up with our one solution is exactly 1/2. All right, let's look at a second example. I notice that the highest power here is 2, meaning I have two solutions. All right, and now to solve that, we're going to take the function and set it equal to 0. I'm going to solve this using square roots, meaning I need to add 2 to both sides, giving me x squared equals 2. And if I square root the left and the right, I'll get my two solutions of positive or negative square root of 2. So it looks like one solution, but remember this positive negative symbol gives me those two solutions that I'm looking for. All right, well, here's the kind of the reverse of that fundamental theorem of algebra. If you know the solutions of a polynomial, you can write the original polynomial by using those solutions, okay? So what that really means is you use your zeros to write your factors, and then you just multiply the factors together to get back to that original function. Let's see how to do that with an example. So here I'm given 3 solutions, positive 3, positive 1, and 7. Meaning that x minus 3, x minus 1, and x minus 7 are factors. Because notice if I would plug in positive 3 to this first factor, I would end up with 0. All right, so this is the factored form of our polynomial. And now we're just going to multiply everything together to get the original. I'm going to start with the x minus 1 and x minus 7. So we're going to distribute the x. giving us x squared minus 7x. And then distribute this negative 1, giving us minus 1x plus 7. All right, and then we will just bring down the x minus 3. And we're going to distribute that one more time. First starting with the x. So x times x squared is x cubed. X times negative 7x is negative 7x squared. X times negative 1x is negative 1x squared. And then x times 7 is 7x. And now we need to take that negative 3 and distribute that. Negative 3 times x is minus 3x times x squared. It's negative 3x squared. Negative 3 times negative 7x is positive 21x. Negative 3 times negative 1 is positive 3x. And lastly, negative 3 times positive 7 is negative 21. Now, as you can see, we have a lot of like terms. X cubed is all by itself, however. And now I notice I have negative 7x squared minus 1x squared minus 3x squared. So if I combine those like terms, that is going to give me, let's see, negative 7, negative 8, negative 11x squared. Let's do the same thing with our x terms. I have positive 7x plus 21x makes 28x plus 3x is 31x. And lastly, I have minus 21 at the end. So this is our f of x. That's our original function. It is x cubed minus 11x squared plus 31x minus 21. Let's try that again. Now, with this last example, we have some imaginary solutions. So we need to remember that anytime you multiply I times I, that gives you I squared, which we always replace with negative 1. That's going to be important in the second example. All right, so again, we have these three zeros, 0, 2i, and negative 2i. We're going to write the factors that would give us both solutions. The first is simply x. Then we have x plus 2i and x minus 2i. So we have our three solutions. First, let's FOIL out this. So x times x is x squared. X times negative 2i is minus 2ix. Positive 2i times x is plus 2ix. And then positive 2i times negative 2i is negative 4i squared. And we do still have this x out front. And now we have something that's going to happen here. This minus 2ix plus 2ix cancels, and we end up with x times this x squared minus 4. And then remember, I squared can be replaced with negative 1. So let's do that right away. All right, and then one last step is just to distribute this. So we end up with x times x squared plus 4. And then when we distribute, we get our final answer of x cubed plus 4x. All right, so this right here would be our function. So we would just rewrite it in function notation. F of x equals x cubed plus 4x. And that would have these three solutions that you see up above.